So, you want to learn how to code? You want to learn how to create a program with your own two hands. It probably seems huge, maybe even a little scary, but it's completely doable. You just have to start with the basics. Maybe you hear all these complex words like variables, loops, and data types, and it feels like learning another language from scratch. But the good thing is, you already understand all of these concepts. You use them every single day even. You're just not used to calling them by their programming names. Let me show you what I mean. Let's start with syntax. In any spoken language, like English, we have grammar. Grammar is just a set of rules that helps us understand each other. We know we should say, I am going to the store, instead of store to the am going. Or at least I hope you do. The syntax in programming is the exact same thing. It's the grammar of a programming language. It's the set of keywords in the specific order that's recognized by the computer, so it can perform what you asked it to do. Okay, next up is variables. You use variables all the time in real life. Think about when you're telling a story to your friend and you say, I finally beat that boss. And your friend knows exactly which boss you mean. Because in the conversation, that boss is just a placeholder for something else, like the name of the boss. In programming, we can do the same thing. We use variables to refer to things indirectly. We could tell the computer that boss equals the final boss of the game. And now, anytime we want to talk about the boss, we just use the variable that boss. The variables are just a way to store a piece of information. Give it a name and then reuse or change that information inside it multiple times if you need to. Okay, now data types. Just like things in real life can be categorized into types, there are also some important types in programming. That's where data types come in. There are different things programming languages can do with different variables, which is why it's important to know that these variables have types. Integer. An integer is just a whole number, like for example, player level equals 10, or the ammo count equals 30. Float. A float is just a decimal number, like boss health equals 98.5, or the experience percentage is 0.75. String. A string is synonymous with text. It's called a string because it's a string of characters, like letters and symbols. For example, a string can be player name equals mystery git. Character. This is just a single alphanumeric character, like getting the grade A or B at the end of a mission. Boolean. This one is really simple. It's just true or false. Like for example, is player alive equals true, or is door open equals false. See, you already know what these are. Now let's talk about two that are about grouping data. Arrays. An array is just like writing down a list of things on paper so you can look at them later. It's like your inventory in a game. For example, inventory equals, then you open the square brackets, sword, health, potion, key, and so on. It's a list and all the items are in a specific order. Dictionaries, or maps. These are also like lists, but instead of just a simple list, it's a list of pairs. It's like writing notes, but putting a key like a date or a title in front of each note, so you can find it more easily later. For example, you could store a player's settings like this. Settings equals the difficulty is hard, music volume is 8, and subtitles are true. With dictionaries, you don't care about the order as much, because now you can just look things up by the key value, just like when you look up something in a dictionary. This next part is where your code starts to make you feel like a real programmer. Let's talk about conditions. The phrase, if this, then that, or else, is the absolute backbone of every program ever made. And the good thing for us is that programming languages use those exact words, if and else. For example, if player health is less than 0, then play the game over screen. Else, let the player keep playing. Or if the player presses the jump button, then make the character jump. That's it. That's all conditional logic is. It's just checking if something is true and then doing something based on that result. Now, what if you wanted to keep checking that condition? That brings us to loops. Okay, now imagine you are a game. You don't just check once if the player is pressing a button. You have to check constantly, like 30 or 60 times every second. A loop lets you do exactly that. It just runs a block of code over and over again until a certain condition is met. For example, while the game is running variable is true, continue checking for player input. Or you can loop a set number of times. Like if you know you need to spawn 10 enemies, you can tell the program to loop 10 times, and in each loop, it runs the spawn enemy code. Okay, one last big concept, functions. In the real world, if we need to do a specific job, we create a tool. We invented the hammer to hit nails, and we invented the light bulb to create light. A function in programming is exactly that. It's a reusable tool that you create to perform a specific job. Imagine in your game you have code that makes the player jump. This code might be 10 lines long, let's say. It has to check if the player is on the ground, apply an upward force, play a jump sound maybe, and everything else. Instead of writing those 10 lines of code every single time you need the player to jump, like when they press the button or if they hit a bounce pad or something, you just put all that code inside a function called player jump. Now, anytime you need the player to jump, you just use that same tool, player jump. You already created this, so don't make yourself do it again. And sometimes, a tool needs extra context to work. If you have a tool called deal damage, it needs to know who to damage and how much damage to deal. Those bits of extra context are called parameters of a function. So you might call your function like this, deal damage, and you specify the enemy and how many points of damage it will deal. The function takes that context and uses it to do its job. Alright, now for the final round. You'll hear this term everywhere. Object-oriented programming, or OOP, or OOP. It may sound super complex, but I want to teach you that it's just about grouping things together. We just learned about variables and functions. But what if you could bundle all the variables and all the functions that relate to one single concept into one big container? That container is an object. Think about an enemy in a game. It has some properties like it has health, or it has a position, it has an attack power. And it can also perform actions. Maybe it can move, it can attack the player, or it can take damage. Instead of having all those variables and functions floating around randomly, OOP lets you create an object, or as I like to call them, a concept. The enemy object holds all of its own data and all of its own tools. This object could be a real-life thing like a ball or a player, or it could be an abstract concept like a chat service or a level manager. So when should you create an object? Whenever you realize you have one or more variables or one or more functions that can all be grouped together by a common concept, that's when you create an object. And now you know how to program. Okay, but seriously, we just covered all the basics of programming, and hopefully you saw that every single one of these has a parallel in your real life, or maybe in games that you've played. So let's do a quick recap. The syntax is the grammar of the language you use. Variables are like placeholders for storing data. Data types is like the kind of data you're using, like numbers, text, or true or false. Arrays and dictionaries are ways to store multiple things together. Conditions like if and else are just about making decisions. Loops are just a way to repeat a block of code. Functions are reusable tools to perform a specific job. And objects, from object-oriented programming, are ways to bundle related variables and functions. Programming is not magic, it's just about learning the specific way to describe these things to a computer. So do subscribe if you found this helpful, and good luck with programming. That's all for now. See ya.